everyone, this is Mrs. Snowbeck. Today we are going to do Unit 8, Lesson 10, and we're going to be finding areas of similar figures. Remember, if two polygons are similar, that means they have the same shape but different sizes. So it's like one is a miniature version of another one. So if we go up here and we fill in the blank, two polygons are similar if and only if their corresponding angles are congruent. Their angles are still going to be the same size, but their corresponding sides are not. Their sides are going to be proportional. And you can kind of see that from the picture here. The angles all have the same marks, like angle A and W both have one mark. That means they're congruent to each other. And B and X each have two marks. They're congruent to each other. But the side between A and B is not congruent to the side between W and X. They're going to be proportional to each other. So let's move on to the big idea for today. It says if two polygons are similar, then their areas are proportional to the square of the scale factor between them. That sounds kind of confusing. I'm going to give you 4 steps for solving these problems. Let's write down the 4 steps, then we'll try some, and hopefully that'll clarify what we're talking about. So step number 1 is going to be find the scale factor. Find the scale factor. Step number 2 is square the scale factor. Square the scale factor. Step number 3 is set up the equation. Set up the equation. And step number 4 is cross multiply. So let's just go straight to number 1 and I'll show you what I'm talking about. It says if triangle JKL is similar to triangle PQR. See that one squiggle right there? That means is similar to. That means they're the same shape but different sizes. And the area of triangle JKL is 30. Let's put a 30 in JKL. Find the area of triangle PQR. I'm going to put a question mark in triangle PQR. Now I can't just find the area in PQR because I only have one side. I can't use like my area of a triangle formula. But let's follow the 4 steps up above and see if we can get those to work. The scale factor between these two shapes is going to be 12 to 15. And I know that because JK, first 2 letters right here, match PQ, first 2 letters in the other triangle. So the scale factor, let's write this down. Scale factor is 12 to 15. That's how the 2 triangles compare. So the next step says square the scale factor. So we take 12 over 15 and we square them. So 12 squared over 15 squared. Step number 2 is set up the equation. So then we're going to say equals 30 over x because we don't know the area of the bottom triangle or PQR. Now, the reason we have to scale the factor is because we're comparing it to areas, and areas are square units. Step number 4 is cross multiply. So now we're going to cross multiply, which we've done a lot of. And so we're going to multiply 12 squared times x. So 12 squared is 144 times x. And then we're also going to do 15 squared times 30. So go ahead and grab a calculator and type in 15 squared times 30. You should get 6,750. Divide by 144. And x equals, go ahead and divide it. I got 46.88 square inches, or inches squared. So if the area of the top triangle is 30, the area of the bottom triangle will be 46.88 because they're similar and we can figure out the area based on the scale factor between them. Let's try number 2. So let's go through our 4 steps. Step number 1 is find the scale factor. So the scale factor, I'll just abbreviate SF, is 8 to 5. The 8 matches up or corresponds with the 5. Second step is square the scale factor. So you go 8 squared over 5 squared equals, now we set up the equation, step 3. Well, the first rectangle has an area of 32, and the second rectangle, we don't know the area, we're trying to find it, so we'll call that x. Now to find x, we have to cross multiply. So we're going to multiply 8 squared times x. That's going to be 64x. 8 squared is 64. Then we're going to multiply 5 squared times 32. 5 squared is 25 times 32, I think turns out to be 800. You can check that. Divide by 64. And x equals, go ahead and type it in. I got 12.5 centimeters squared. So if the area of the blue rectangle is 32, the area of the green rectangle is 12.5. Let's try another one. Number 3, find the area of the figure on the right. Okay, so these are similar figures. We're going to write down the scale factor. The scale factor is 6 to 8. So in the second step is we square them. 6 squared over 8 squared. And then we set up our proportion, or our equation, equals 13.5 over x. So we square the scale factor because we're comparing areas, which are in square units. Cross multiply. 6 squared is 36, so 6 squared times x is 36x. 8 squared times 13.5, go ahead and type it in. I got 864. Divide by 36. X is 24, and we can label that feet squared. So if the first triangle had an area of 13.5 square feet, the second triangle will have an area of 24 square feet. Let's try number 4. So one of the things we have to figure out is the scale factor. And down here I see a 6, and it's between D and C. D and C are the last 2 letters. They should match with RS. And RS is over here with the 9. So one of these rectangles must be turned sideways. But the 6 and the 9 are corresponding sides. And so the scale factor is 6 to 9. It does tell us the area of ABCD is 48, so let's put a 48 in the first one. And they want us to find the area of PQRS. All right, well, we know the scale factor is 6 to 9, so 6 squared over 9 squared. Square the scale factor, and then make your equation. So equals 48 over x. Make sure that the 6 and the 48 align. So like if I put the 6 on top in the first fraction, the 48 had to go on top in the second fraction. Cross multiply. So we get 6 squared, which is 36 times x. And we get 9 squared times 48. Go ahead and type that in. 9 squared times 48. 3,888 is what I got. Now solve it. So divide by 36. And x is 108. And it's going to be inches squared. It's the area of the second rectangle. Okay, to finish up, these we're going to follow the same steps, but but it's going to be a little different because it says use the given areas to find the scale factor of the figure on the left to the figure on the right. Then find x. So notice, we're going to go through the same 4 steps. We want to use the lengths as our scale factor. So x and 6 are the scale factors. I'm going to write that down. Scale factor is x over 6. So step number 1 is find your scale factor. Step number 2 is square that. So we're going to do x squared over 6 squared equals, now our areas are already squared, so we just used 50 over 72. We just use those as is. They're already in square units. All right, there's our equation. Now we're going to cross multiply. So we're going to have 72x squared. Ooh, 72 times x squared. And then we're going to have 6 squared times 50. Now 6 squared times 50, if you type it in, is 1,800. Divide both sides by 72. X squared turns out to be 25. And then we don't want x squared, we want just x. So we have to square root to finish this off. Now, technically we get plus or minus 5, but since it's the length in looks like a trapezoid here, then we're just going to use the positive 5. So to fill in our answers, our scale factor is 5 to 6, and x was 5. Let's try the last one. The scale factor is the length of the sides as a fraction. So looks to me like we have a 40 and an x. Let's write that down. Scale factor is 40 to x. So let's go through our steps. We take the scale factor, 40 over x, and we square them. So 40 squared over x squared equals 400 over 64. As usual, cross multiply. So we're going to have 400x squared, and then we have to do 40 squared times 64. This is a big number, 102,400. Divide both sides by 400. X squared equals, go ahead and type it in. I got 256. And now we want regular x, not x squared. So how do you undo a square? You have to square root. And the square root of 256 is a nice number. Try typing it in. You should get 16. So to write down our final answers here, our scale factor is 40 to 16. 40 to 16. And our x was 16. That ends the notes for Unit 8, Lesson 10. So you guys go ahead and try the assignment. Have a great day. See ya.